Good morning. Our next topic is orbital parameters. Kepler's law apply in general to satellite motion around a primary body. For the particular case of Earth orbiting satellites, certain terms are used to describe the position of the orbit with respect to the Earth. First one is sub-satellite point. This is the path traced out on the Earth's surface directly below the satellite. Apogee, the point farthest from the Earth. Figure 2.3 shows the height of the apogee as HA. Perigee, the point is point of closest approach to Earth. The perigee height is HP. Line of apsides, the line joining the perigee and apogee through the center of the Earth. Ascending node, the point where the orbit crosses the equatorial plane going from south to north. Descending node, the point where the orbit crosses the equatorial plane going from north to south. Line of nodes, the line joining the ascending and descending nodes through the center of the Earth. Inclination, the angle between the orbital plane and its equatorial plane. It is measured at the ascending node from the equator to the orbit, going from east to north. The inclination is given as in figure. It will be seen that the greatest latitude, north or south, reached by the subsatellite path is equal to the inclination. Prograde orbit, an orbit in which the satellite moves in the same direction as the Earth's rotation, shown in the following figure. The prograde orbit is also known as the direct path. The inclination of the prograde orbit always lies between 0 to 90 degrees. Most satellites are launched in the prograde orbit because the Earth's rotational velocity provides part of the orbital velocity with a consequent saving in launch energy. Figure shows the prograde and retrograde orbits. Retrograde orbit, an orbit in which the satellite moves in the direction counter to the Earth's rotation, as shown in figure. The inclination of the retrograde orbit always lies between 90 degree and 180 degree. Argument of perigee, the angle from ascending node to perigee measured in the orbital plane at the Earth's center, which is shown in figure 2.5, which is in the direction of satellite motion. Right ascension of the ascending node to define completely the position of the orbit in space. The position of the ascending node is specified. However, because of the Earth spins while the orbital plane remains stationary, the longitude of the ascending node is not fixed, and it cannot be used as an absolute reference. For the practical determination of an orbit, the longitude and time of crossing of the ascending node are frequently used. However, for an absolute measurement, a fixed reference in space is required. The reference chosen in the first point of Aries, otherwise known as the vernal or spring or equinox. The vernal equinox occurs when the sun crosses the equator going from south to north, and an imaginary line drawn from this equatorial crossing through the center of the sun points to the first point of Aries. This is the line of Aries. The right ascension of the ascending node is then the angle measured eastward in the equatorial plane from the lambda line to the ascending node, shown in figure. Mean anomaly. Mean anomaly M gives the average value of the angular position of the satellite, the reference to the perigee. For a circular orbit, M gives the angular position of the satellite in the orbit. For elliptical orbit, the position is much more difficult to calculate, and M is measured as an intermediate step in the calculation. True anomaly. The true anomaly is the angle from perigee to the satellite position measured at the Earth's center. This gives the true angular position of the satellite in the orbit as a function of time. This figure shows the argument of perigee and the right ascension of the ascending node. Orbital elements. Earth orbiting artificial satellites are defined by 6 orbital elements referred to as Keplerian element set. One is semi-major axis. A fixes the size of the orbit. Eccentricity E gives the shape of the ellipse. Mean anomaly M0 gives the position of the satellite in its orbit at a reference time known as the epoch. Argument of perigee gives the rotation of the orbit's perigee point relative to the orbit's line of nodes in the Earth's equatorial plane. Inclination I fixes the plane's position. Right ascension of the ascending node omega relates the orbital plane's position to the Earth. Then apogee and perigee heights. Although not specified as orbital elements, the apogee height and perigee height are often required. The length of the radius vectors at apogee and perigee can be obtained from the geometry of the ellipse. Ra equal to A into 1 plus E. Rp is A into 1 minus E. Ha equal to Ra minus capital R. Hp is Rp minus small r. Thank you.